Guys, this video is going to go through describing transformations. So we've done it algebraically and we've done it graphically. Now we're going to kind of describe more what happens when we do a transformation. We're going to specifically focus on linear transformations. Okay, so just as a quick refresher, we have these rules. You should have these in your notes, but you're going to want to have that kind of somewhere near you so you can look at this as well. All right, so here's the type of problem that you might see. So I might give you a function, okay, f of x equals 4x minus 2. So right now you guys should know that this is a line. You know the slope is 4. You know the y-intercept is negative 2. Now here's your first transformation. So it says take your function, add 6 to it. So first thing that you are going to want to do is just rewrite your function, 4x minus 2, and then it says add 6 to it, so plus 6. Okay, now I'm going to do some combining here. So I'm going to combine my normal numbers here, so I end up with 4x plus 4 as my new function. Okay, I'm just going to add the f of x in it right before it. Okay, so here is my new function. Now, here's what you are going to have to be able to do. So I'm just highlighting that quick. Okay, if you look at the original one, I'll just kind of box that up here. If you come look at this one and you compare it to this other one, what happens? Now, there should be a couple things that you know. Okay, first thing that you should notice is that just this rule in general, if it says add 6, that's going to slide the whole line up 6. So you guys need to be able to recognize that. So it's a translation up 6 units. Okay, so that would be one thing you would need to describe. Now, another thing I would want you to describe is how does the slope change? So if you look at the slope in the original one, it's 4. And if you look at your slope in your new one, it's also 4. So the steepness of the line stayed the same. And that would make sense. If you're just sliding a line up, the steepness would stay the same. So I'm going to write that the slopes stayed the same. Okay, now the other thing you would want to describe is the y-intercept on a line. Those are kind of the important things, the slope, the y-intercept. So look at the original y-intercept of negative 2. Now it's 4. Okay, so the y-intercept went from negative 2 up to 4. Well, that's actually up 6 units. So the y-intercept went up 6 units. Okay, so that is what I would want you to describe on one like that. Okay, let's try the second one. Okay, I'm just going to use a different color. So on this one, it says take negative 3 times your function. So I'm going to take negative 3 times my entire function, which was 4x minus 2. Okay, now I'm going to rewrite that. I'm going to multiply it out. So I end up with negative 12x. And then a negative times a negative is a positive. So here is my new function. F of x equals negative 12x plus 6. Okay, so now on this one, I'm going to do some comparing as well. Okay, so first thing I notice is that I am timesing it by negative 3. Okay, so first thing I know is when I times something by 3, when I times the entire function by something, it's going to stretch or shrink vertically. Since it's a whole number, it's going to stretch vertically. So I'm going to list that to start with. Okay, next thing I might notice is that negative sign. Now, if I times a function by a negative out front, you should kind of realize that that's going to make it reflect. And if it's out front, it's over the x-axis. So it's going to be a reflection. And because it's out in front of the function and not in the inside, like right there, it's going to be across the x-axis. So it's going to reflect the line. Okay, next thing, let's look at the slope. My original slope was 4. My new slope is negative 12. Well, the slope, it's 3 times as steep. From 4 to 12, that's 3 times. Okay, so I'm going to write it's 3 times as steep. Also, my line changed direction, right? It was a positive slope. Now it's a negative slope. You could mention something about that. So now it's a negative slope. Okay, and then also my y-intercept changed. How did it change? Well, it went from negative 2 to 6. Well, again, it multiplied by 3. Okay, actually multiplied by negative 3. So my y-intercept also changed. Okay, so you could say a couple different things about it, but it multiplied by negative 3 to get it to 6. All right, so all of those things you would want to describe, and I didn't even have to graph this. Now, you could graph it if you had a graphing calculator or a sheet of paper, but you should be able to describe all of these things, especially on a line, without graphing it. All right, let's take a look at another one. So again, same function to start with. This time it says take the x value, subtract 2. Okay, now I'm going to come down here. Before I even do this, I know if I have this rule and I'm subtracting 2 on the inside, if I'm subtracting 2 from the x value, it actually translates it to the right 3. Okay, I know that based on my rules. So it's going to translate it right 3. I know that before doing anything else. Okay, so when I'm going to rewrite this, I'm going to start with my 4, and then it says subtract 2 from just the x value. So here's the x value, subtract 2 from it, and then it still says minus 2. Okay, now I'm going to rewrite it. I get 4x, distribute minus 8 minus 2. So finally, my new function is 4x minus 10. Okay, I'll just add my f of x out there. So here is my new function. All right, now we want to describe how it changes. So let's take a look at the slope. Okay, my original slope is 4, so is my new one. Okay, so the steepness of the line stayed the same. Okay, so I'm going to say slope is the same. Okay, steepness still the same. Okay, second thing I want to look at is my y-intercept on a line. Those are kind of the important things. So it was -2, now it is -10. Okay, so my y-intercept obviously shifted, so I'm going to write my y-intercept. Okay, from -2 to 10, it actually increased by 8, but we're just going to say your y-intercept shifted. Okay, so again, I just described it. It's still a line with the same steepness. It just translated to the right 3, so that's going to change where your y-intercept ends up. Okay, let's look at one more. Okay, let's look at this last rule here. So this one, it says, just take the x value, multiply it by 4. So I'm going to start by writing my 4 that was out front, put parentheses. Now it says times that x value by 4. So I got to times my x value by 4 and then subtract 2. Okay, let's multiply this out. 4 times 4 is 16x minus 2. So here is my new function. Okay, it looks a lot different if you guys look at this. But first thing, hopefully you realize, when I times just the x value by 4, okay, this is going to change horizontally. Okay, so it's going to be, since it's a number bigger than 1, it's going to be actually a horizontal compression. So it's going to shrink horizontally. Horizontal compression. I'm just going to write compress because that's all I can fit. Okay, second thing, my slope. Obviously, my slope went from 4 to 16, so it's 4 times as steep. Okay, so you can say your slope was 4 times bigger, or it's 4 times as steep. And then look at my y-intercept. It stayed exactly the same. So my y-intercept stayed exactly the same. So those are the things that you would want to describe on the graph of a linear transformation. All right, let's do 2 more, but this time let's do it with a parabola. Okay, so this parabola is x squared plus 1. It's a basic U shape, but it's kind of just up a little bit. So let's transform it using this function. So if you see one like this, it says, take your function, make it everything in it the opposite. So I'm going to put the negative symbol, and then put my whole function, x squared plus 1. Okay, I'll distribute it, so I end up with negative x squared and negative 1. Here's my new function. Okay, so let's think about what happened. So first thing, again, you can look at your notes for this. You guys can use your notes on this. So as long as you took new notes, you should be okay. If that negative sign is out in front, it actually is a reflection. I'm just going to change colors. It's going to be a reflection across the x-axis. Okay, so it's going to flip over the x-axis. Okay, second thing, you guys might notice this was, so think about this. This was a positive, so my u was going up. Now it's negative, so now it's going to be down. You could describe that. Okay, that would make sense. When it reflects across the x-axis, it's going to flip upside down, right? If I flip it across the x, it flips upside down. So you could describe that if you wanted. Now it's upside down u. Okay, how about the vertex or I should say the y-intercept, sorry. It was 1, now it's negative 1. Okay, so we can say the y-intercept is the opposite this time now. Okay, so that is all I really would need you guys to describe on that one. Okay, let's check out the second one. So this one says take the whole function, add 3 to it. Okay, before I even do anything to this one, hopefully you know if you're adding 3, it's going to translate up 3 units. So it's going to slide this function up 3 units. So it's a vertical translation. So when I transform it, it says take my function. So x squared plus 1 was my original function. Now add 3 to it, so plus 3. I end up with x squared plus 4. Here's my new function. Okay, so obviously I know it translates up 3. It's still just a basic u. It didn't get wider, it didn't get skinnier, so it stayed the same. But all that happened was it slid up 3, so my y-intercept also went up 3 units. Otherwise, it's the same u, exactly the same u shape. All it did was slide up 3 units. Okay, so if that was my graph, all it did was slide up 3 from where it was. All right, one last thing that I would like to show you is sometimes you might see a double rule, and we're going to stick with pretty basic ones. You're going to get more of this when you get to geometry and algebra 2, but I just want to show it to you real quick. So sometimes you might see a double rule. So I don't really care what my original function was, but what would this rule tell me to do? So let's start with this part. This first part, I'll just kind of highlight it. So x minus 3, if you just are doing it to the x value, hopefully you know that this would, whatever my function is, this would translate it 3 units to the right. Okay, so I'll write that. And then if you're adding 1 to your function, that's going to translate it 1 unit up. 1 unit. So that would be vertically, and then this part would be horizontally. Okay, so that was just kind of a double rule. So whatever your function was, it would go right 3 and up 1. Okay, this bottom one, same thing here. Let's look at this part. This is going to be a translation. And if it's just to the x value, this is going to make it go left 2 units. Okay, and then this part, minus 6, that's going to make it translate down 2 units. Okay, so that's kind of what the double rules look like. We're not going to get any harder than that. All right, so your learning goal after this lesson would be, if I give you a linear function, we're mostly just going to do linear functions or very basic parabolas. If I give you a function and I ask you to transform it using a rule, something like that, could you rewrite the function, so write your new answer, and then could you describe with a couple bullet points what happens to it? So could you describe the slope? Could you describe the y-intercept? Okay. Anything else? Does it stretch? Does it shrink? Any of that kind of stuff you guys would need to describe. Same thing with a basic parabola. If I give you a pretty easy one like that, does it shift right? Does it shift left? Does the y-intercept change? Does it compress? Does it stretch? So you would just need to be able to describe these things, and you can use your notes. Please let your math teacher know if you have any questions, and I hope you guys have a great day.